Hi everybody, welcome back for lesson 25.4, which is going to talk about angles formed by secant and tangent segments. So we're going to be using a note sheet today, not the book, so make sure you have that. It's attached in Google Classroom. Something to write with and a calculator. Okay, let's go ahead and get started. We're going to talk about describing relationships among the angles formed by tangents to a circle or by angles formed by secants to a circle. So we have a new vocab word here, a secant line. So a secant line is a line that goes through the circle and touches 2 points on the circle. Okay, so it's going to touch 2 points on the circle. Okay, so an example of a secant line, if I draw one in here, would be something like this. Okay, so it's a line that goes through the circle and touches at 2 points. This is an example of a secant line. Now don't forget, we've already learned about tangent lines before. Remember, a tangent line only touches 1 point on the circle, so something like this. Or if it touches at 1 point, we call that our point of tangency. So that is an example of a tangent line. Okay. So in a previous video, we learned about the relationship that's formed when we have two chords, okay, and the angle that's formed inside the circle. Okay. So remember we had that formula that our angle x was equal to 1/2, and then our arc A plus arc B. Okay, so that's for when we have angles that are formed inside the circle when we have two chords. So today what we're going to learn about is what happens when we have angles that are outside the circle. Okay, so this angle A in each picture. See how it's outside the circle. So it's either formed by a secant line. So secant means they pass through 2 points each on the circle. Okay, let me use maybe some highlighters here. So this is a secant line and this is a secant line. So secant. Okay, or when we have a secant line and a tangent line. Okay, so one line that goes through 2 points and one line that only touches 1 point. And then if we have a tangent. Now we learned some properties already about those lines being congruent, but now we're actually going to be able to find that angle on the outside. Okay, so we have a new formula for that. Okay, and it's going to be similar to the one above. So our angle here, so let's just say, we'll just say A, okay, angle A is equal to, okay, 1/2, and we're going to do our far arc minus the near arc. Okay, so it's always kind of, we can also think of this as the bigger number, or the bigger arc minus the smaller arc. But if you remember far and near, so for example, if this is angle A, this angle over here is the far arc. The one close to it would be the near arc. Okay. So, or you could take the big arc minus the smaller arc. But if you just remember far and near, it's the one away from it and then the one closer to it. So let's practice that with some problems on the next slide here. So we're just going to start by identifying which line is secant or tangent to the given circle. So looking at this picture, would this be a secant tangent, or tangent? Same thing with the second picture and the third picture. Go ahead and fill in those blanks there. What kind of circles are these? Okay, well in the first one you can see that it only passes through 1 point each on the circle. So this would be an example of tangent. Okay, two tangent lines. Okay, where our middle picture has one tangent line and one secant line because we have 1 point here and then 2 points there. Then lastly, this picture was secant, okay, because they're both passing through 2 points on the circle. Okay, so tangent again is 1 point. Secant passes through 2 points. Okay. All right, let's put our formula to some work here on the bottom. I have lots of examples today, so we might not go through all of them, but there'll be extra ones if you want to practice. Okay, but according to our formula, our angle x here is going to be equal to 1/2 our far arc minus our near arc. Okay, so for this one, if we set it up, x is equal to the far arc would be 90, the near arc would be 30. Okay, so we would equal to 1/2 90 minus 30. So we have 1/2, 90 minus 30 is 60. So half of 60 would be 30 degrees. Okay. Now, it doesn't matter what kind of circle you have. They all use the same exact formula. So it doesn't matter if you have secant, or like in B where we have a secant and then a tangent. Okay, or in C where it's tangent. It doesn't matter what it is. Anytime we have an angle outside the circle, we use this same formula. Okay, so I'm going to have you guys try B here. It's going to be exactly the same as A. So you have X. You want to find the measure of X when the far arc is 170 and the near arc is 40. So go ahead and set that up and solve for X for me. Okay, if you did it correctly, I got that X was 65 degrees. Okay, and here's my work for that. So I took 1/2, 170 minus 40, did my order of operations, and got 65 degrees. Okay. Now let's look at C. If we had to set this up, I would have to take X equal to 1/2. My far arc is 330, but when I try to subtract my near arc, which would be this one here, it doesn't have a measurement. So we have to use some properties about circles to figure out what that arc measurement is. Now remember, the entire circle is how many degrees? Well, our entire circle is 360 degrees. Okay, so to find just this part, I have to take away this major arc here. Well, we know the major arc is 330. So if I subtract that off, I get a leftover measurement of 30 degrees. So that makes my near arc 30 degrees. So now I can finish up and solve this problem. We have 1/2. Okay, 330 minus 30 would be 300. Half of 300 is 150 degrees. Okay. So if you're not given the arc that you need, you can kind of use process of elimination here and properties about circles to find those missing segments. So why don't we look at D here? Okay, D is going to be set up kind of similar, where we're given this arc, we're given our minor arc, and another arc. So we need to first figure out what's the length of our far arc there so we can use our formula. Because right now we only know the near side and 2 other arcs. So maybe I'll help you start this problem and then have you guys finish it. But remember, a full circle is 360. So if I subtract my other 3 arcs, I should get just what's left over, this piece right here. Okay, so that means we would take 360, subtract 160, subtract 106, and subtract 34 to get the leftover arc there. So if I do all my subtraction correctly, we should get that far arc measurement to be 60 degrees. Okay, so let me clean up my picture here a little. Okay, so we just figured out that this piece was 60. Okay, so now that you have the near arc and the far arc, plug it into your formula and solve for X. Okay, I got X was 13, and here's my work. So 60 minus 34 is 26. Half of that would be 13 degrees. Okay. Now E and F are very similar problems, so I just put the answers here in case you want to try them on your own, but I'm going to move on to the last page here. Okay, so on the last page, we're going to be doing some equations. So in example 3 and part of example 4, we're going to be solving for X. So remember, our formula is our angle is equal to 1/2 the far arc minus the near arc. So in this problem, our angle here is 56. Okay, and then our far arc would be, we have 160 minus our near arc, which is X. So you have to do a little problem solving here. Now, 2 ways to do it. You could distribute that 1/2 if you want, but I'm just going to multiply it out on both sides to get rid of it. So 2 times 56 would be 112 is equal to 160 minus X. Now, if I subtract, let's hear what I'm going to add the X to the other side, and then I'm going to subtract 112 over. That way I don't have to worry about any negatives. Let's see, 160 minus 112. I had a little extra 0 there on accident. We should get that X is what, 48 degrees. Now, however you chose to solve it, it doesn't really matter as long as you can get the right answer. But there you go. Okay, so I'm going to have you guys try B on your own. It's the same idea. Your angle is 48. So you're going to set 48 equal to 1/2 your far arc minus your near arc. So go ahead and set that up and solve for X. Okay, when I did this, here's the answer that I got. I got x was 230. And here's my work. So I multiplied both sides by 2 to get rid of the half. That gave me just 96. So I added the 134 over. Okay. And make sure your answer makes sense. Okay, we should never get any negatives because we're talking about measurements of arcs and angles. Okay. Also, this is supposed to be your bigger arc. The farther arc should be bigger than your near arc. So make sure your answers kind of relay that. Okay. All right, let's try some that are a little tougher. I'm going to go through, this should say A, the first one with you guys. And then you guys will try B. Okay, so we're solving for x in both of these. It says find the measurement stated. So we're going to find x. So let's look at our angle here. Angle S is 5 plus 12x. We're going to set that equal to 1/2. Okay, 1/2. My far arc, which is 160, minus my near arc. So 13x plus 2. Now we have to be careful with this one because we're subtracting that whole thing, not just the 13x. So when we try to simplify these parentheses, we would have minus 13x, but then also minus 2. Okay, you kind of have to like distribute that negative in a way because you're subtracting the entire statement there. So really this is going to give us, if I get rid of the 1/2, I'm going to multiply it on both sides. So that's going to give me 10 plus 24x equal to 160 minus 2 would be 158 minus 13x. Okay, so now let's get all of our, I'm going to add this over, get my variables on one side. So that would be what? 37x. Get my constants on the other side, so 148. So if I divide that out, we should get that x is 4. So definitely a little tougher algebra here. Anytime you're subtracting something, make sure you subtract the entire piece if there's 2 terms. Okay, so I'm going to have you guys try B. It's similar. Now your far arc and your near arc are both numbers, so you don't really have to worry about that distributing thing we had to do on problem A, but that's okay. So set it up. You have your angle B equal to 1/2 far arc minus the near arc. So go ahead and solve for x for this one. Okay, I got x was 9. And here's my work in case you need to check it out, in case you didn't get that answer. Okay, so 1/2 times 60 minus 78. I just did that all in my calculator and got 41. Subtract 14 on both sides, divide by 3. All right, let's just wrap it up with 2 last questions here. We have to find the measure of angle EFH. EFH. So we're finding basically angle F here. Okay, so let's set it up. Our outside angle, 18x minus 1, is equal to 1/2. My far arc, so -1 plus 83x, minus my near arc, so minus 95. All right. I'm going to get rid of the 1/2. I'm going to multiply by 2 on both sides, making sure to distribute that 2. So 26x minus 2. Here, let's see, we have -1 minus 95. So that's going to turn into 83x minus 96. And now we can solve this linear equation. A little bit more room. Okay, so let's see. Let's subtract the 26x, get those on both one side. So 83x, okay, minus, oh, this should be 36. Hopefully you caught me on that. 36, not 26. So minus 36 on that side. Should give us, what, 47x. Okay, similarly, let's put our constants on the left side. So I'm going to add 96 to both sides. So it's going to be equal to 94. So if I solve for x correctly, divide both sides by 94, I should get x is 2. Now remember, x is 2, but that's not what they asked us to find. They asked us to find the measure of angle EFH. So we have to find this angle here. So 18 times 2 minus 1. Now I'll see if I do my math correct on this one. 36 minus 1 Our answer is 35 degrees. Now these ones have a lot more algebra with them, but that's okay. Just set it up, same formula. I always like to get rid of the 1/2 by multiplying by 2. Just make sure you distribute it. If you have a variable expression on the left side, distribute it through. And then clean up like terms, and then after that, it should be a nice linear equation for you. So you guys try D. I want you to find the measure of arc, RP. So set it up. You have your angle here, 50 degrees, equal to 1/2 your far side minus your near side. Solve for x, and then once you're done, plug it into this arc and find what arc RP is. Okay. If you did it right, I got the answer of 44 degrees. So setting it up, 50 is equal to 1/2 37x minus 4, and then minus 11x. So if you clean up your like terms here, that's 26x minus 4. Get rid of the 1/2 by multiplying by 2 on both sides. You should get that x is 4. So plugging that into 11x gives you 44. Okay, so we went through a bunch of different types of problems for these, but just remember it all comes from that same formula that was on the front side here, or on this first page. Okay, your measure of your outer angle is 1/2, the far arc minus the near arc.